In this very lesson, we shall be looking at the factorial approach under the binomial theorem. In our previous lesson, we learned how to expand a binomial expression using the combination approach, and this is the formula that we used. In this very lesson, we shall be looking at the factorial approach. One interesting thing is that the factorial approach can be deduced from the combination formula. So let's look at that one. So we have n combination 0, a raised to the power n, b raised to the power n, where a is the first term, b is the second term, and n is the power of the binomial expression. So we are looking at this very term, the first term. So let's look at the first term, this one. So we are saying that, so let me write it here, a plus b raised to the power n. So we have n combination 0. And we have already established that by definition, n combination 0, we are going to get n factorial all over n minus 0 factorial 0 factorial. So from here, we can get n factorial, n minus 0 give you n factorial, and then 0 factorial. So we have n factorial all over n factorial, and then 0 factorial is the same as what? 1. So we have that. Realize that this will cancel this, so we have 1 over 1, and that gives us what? 1. So it means that our n combination 0, we are getting 1. So we have a raised to the power n. Any number raised to the power 0 is what? 1. So we are getting the whole of this to be a power n. Now let's look at the second term. We have n combination 1. So let's bring our addition. N combination 1, by definition, we have n factorial all over n minus 1 factorial, and then what again? 1 factorial. So we have n factorial all over n minus 1. 1 factorial is the same as what? 1. So we are done with it. Now we know that n factorial is giving us what? n minus 1, n minus 2, and so on. Now since we have n minus 1 factorial here, we can decide to end at this very part so that we can clean this, and then we add our factorial to it. So it means that in place of n minus n factorial, we can write this. So we have realize that this can cancel this, we are left with what? N. So it means that n combination 1, we are having what? N. So we have n, and then we add this part, we have a n minus 1 b1. So we are done with this. Let's look at the third term. So we have our addition. So we have n combination 2. N combination 2. You know that n combination 2 gives us n factorial, n minus 2 factorial, and then what again? 2 factorial. Now we know that n factorial can be written as n minus 1, n minus 2. Since we have n minus 2, we can end at this very point. And then we are left with n minus 2 factorial, and then 2 factorial. So realize that this can cancel this. We are left with what? n minus 1 all over what? 2 factorial. So in place of n combination 2, we are going to write the whole of that. So we have n minus 1. Let's add this one. So we have all over 2 factorial, and then we have a n minus 2 b power 2. Let's take it that there is another one here, which is going to be n combination what? 3. So n combination 3, we are going to get n factorial all over n minus 3 factorial 3 factorial. So you know that n factorial is the same as n minus 1, n minus 2, n minus 3 factorial. Since we are having n minus 3 factorial, we can end it. And then we have n minus 3 all factorial multiplying 3 factorial. So you realize that this can cancel that. We are left with n minus 1, n minus 2 all over what? 3 factorial. So in place of n combination 3, this is what we are going to write. So we have n minus 1, n minus 2 all over what? 3 factorial. And then we have our a n minus 3 b power 3. Now we can continue up to b power n. Now with this very part, we can have n minus 1, n minus 2, n minus r plus 1 all over r factorial. And then we have our a n minus r b r. So this is the formula that we are going to use for the factorial approach. This is the formula that we are going to use for the factorial approach. So let's take examples and then see how best we can use it. So we have our first example. We have to expand this using the factorial approach. So first we have to identify our n and our first term, our second term. Our first term is this, and then this is our second term. And then we have our n is equal to 3. Good. So once we are done, we can just substitute these parameters into the formula. So let's do that. We have our a. Our a is what? X. So we have x raised to the power what? 3. Then we have plus. Our n is what? 3. So we have 3. A is still x. X is what? 3 minus 1 will give us what? 2. And then we have our b to be what? Y. So we have y plus our n is what? 3 bracket 3 minus 1 all over what? 2 factorial. Our a is what? X. We have 3 minus 2, and then our b is what? Y. So we have y raised to the power 2. Now we have plus our n is still 3, and then we have 3 minus 1, 3 minus 2, all over what again? 3 factorial, all over 3 minus 3, and then we have our x. The moment you have the second term having the whole power of the binomial expression, which is this, you end there. So let's do some algebra here. We have x raised to the power 3. This will give us 3x squared y plus 3 brackets. This will give us 2 all over what? 2 factorial. Then we have x. This will give us 1, and then this will give us 2 plus we have 3. 3 minus 1 will give us 2. 3 minus 2 will give us 1 all over what? 3 factorial. And then we have x raised to the power 0, y raised to the power 3. We still have x raised to the power 3. And then we have 3x squared y. Now 2 factorial means 2 times 1. And 2 times 1 is still 2. So you can write this as that. You can see that these 2 will cancel these 2. We are left with what? 3x y squared. Now 3 factorial means 3 times 2 times 1. So in place of this, you can write the whole of that. So from here, you realize that 1 will cancel 1, 2 will cancel 2, 3 will cancel 3. We are left with x raised to the power 0 will give us 1. Then we have y raised to the power 3. And that is that. This is as easy as A, B, C, D. So the expanded form of x plus y raised to the power 3, it is this very one using the factorial approach. Let's take our next example. So we have our last example. We have to expand this binomial expression using the factorial approach. So we know that our first term is 2x. And then our second term is what? 1 over 2. So we have first term. And then we have second term. Our n is equal to 3. So we are going to have our first term is what? 2x. So we have 2x raised to the power n. Our n is 3. Plus our n is still 3. Our a is what? 2x. We have 3 minus 1 will give us what? 2. Our b is what? 1 over 2. Plus 3 minus 1 all over what? 2 factorial. Our a is what? The first term, which is what? 2x. 3 minus 2 give us 1. And then we have 1 over 2 raised to the power 2. Then we have plus our n is 3. 3 minus 1. 3 minus 2 all over 3 factorial. And then we have our 2x raised to the power 3 minus 3. That gives us what? 0. And then we have 1 over 2 raised to the power what? 8 raised to the power 3, sorry. So the moment the second term takes the whole power of the binomial expression, we end there. So let's simplify. 8x power 3. This will give us 2x times 2x, and that gives us 4x squared, right? So 4x squared times 3 will give us 12x squared. But remember, we are multiplying by half, so you can write it as this. Then we have 3 brackets. This will give us 2 all over 2 factorial, which is the same as 2. And then we have 2x 1 over what? 4. Then we have this very part 3. 3 minus 1 will give us 2. 3 minus 2 give us 1. All over what? 3 factorial means 3 times 2 times 1. And then this will give us 1. This will give us what? 1 over 8. So we have 8x cubed. Now we realize that 2 cancel 12. We have 6. So we have 6x squared. 6x squared. And then these 2 cancel these 2. We have 3 to 6. So we have 6x all over what? 4. Very good. And then we have this portion. We realize that this one will cancel this one, this two cancel this two, this three will cancel this three. We are left with what? 1 over 8. Let's simplify this one further. So we are going to have 8x cubed plus 6x squared plus 3 over 2x. And finally, we have what? 1 over 8. And that is that. This brings us to the end of today's lesson.